Hey guys, it's Miss Wilkie, and today we're going over dilations. This is our last type of transformation. We've already done translations, reflections, and rotations, so our last one here is dilations. So let's jump in. We got a definition to start us off with. A dilation is a transformation in which a figure is enlarged or reduced, so it can be getting bigger or smaller, with respect to a fixed point C, called the center of dilation. And a scale factor of K, which is the ratio of the lengths of the corresponding sides of the image and the pre-image. So a couple important things about dilations. They will keep the same shape, but not the same size. So it's changing sizes. The angle measures will always stay the same. And then those last two is talking about the scale factor, that K. If your scale factor is greater than 1, your dilation is an enlargement, which means that it's getting bigger. If your scale factor is between 0 and 1, your dilation is a reduction, which means that it's getting smaller. All right, so down at the bottom, we've got a couple of practice problems. It says find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. Okay, so first thing here that we need to clarify, if you notice there's solid lines and there's dotted lines. The solid line is the image and it's the pre-image, and the dotted line is the new image. So if I were you, I'd write it off to the side. The dotted line is the new image. All right, so our formula here for scale factor is new over old. So we're taking one of the dimensions of the new part and comparing it to the same exact dimension of the old part. So on this first one here, the new one is going to be the dotted line. So that means it's just talking about this top section here. So for that, to find this missing distance, the whole thing's 4, the bottom's 2, so if we subtract it, 4 minus 2 is 2. So the dimension for the new one is 2. For the old one, that's going to be the entire side length here, all of this. So our bottom number is going to be 4. So our scale factor is 2 over 4. We always want to reduce if possible. This fraction can be reduced to 1/2. So our scale factor is 1/2. And we said on the last page, if your scale factor is between 0 and 1, it's going to be a reduction. It's getting smaller. All right, number 2, this time we've got our original triangle right here. And then the dotted line is the new one. So it's stretching out a little bit further on the new one. So we're still using the same formula here, new over old. Our new one is the red one, so it's going to be 25. And the old one is the blue one, so it's going to be 20. Again, we want to reduce if possible. Both of those numbers can be divided by 5. So 25 divided by 5 is 5, and 20 divided by 5 is 4. So our scale factor here is 5 over 4. Now this is a fraction, so don't get confused. It is not a fraction between 0 and 1. It's bigger than 1, so that means it's going to be an enlargement. So this picture is getting bigger. All right, on the back side of the page, it says graph the polygon in its image after a dilation, centered C with scale factor K. So they give us our 4 points, P, Q, R, and S. We're going to start by graphing those. P is at negative 10, 0, so we're just going to the left 10. And make sure you label it. Q is at negative 5, 0, so we're going to the left 5. R is at 0, 5, so we're just going up 5 since there's no first number. And then S is at negative 5, 5. So we're going to the left 5 and up 5. There's our 4 points. We're going to go ahead and connect them to make our shape. There we go. Super important, if you notice there's another point, C is at 0, 0. That is not a point on the shape. That is the center. Okay, so if it's centered at 0, 0, everything's fine. We can go on from there. If it's centered from another point, we're going to end up using a different formula. So we're sticking with center at 0, 0 just to make it easier for us, but that is important information still. All right, next part, they're asking, or they're telling us the scale factor is 1 over 5. So we are wanting to multiply all of our numbers by that 1 over 5 to get our new ones. So here's our t-chart. Our original coordinates are x comma y, and we're going to list them all out here. P was at negative 10, 0. Q was at negative 5, 0. R is at 0, 5. And S was at negative 5, 5. So none of that changed. That was just the original coordinates they gave us. Now for the new ones, we just said we want a scale factor of 1 over 5, which means we're multiplying every single number by 1 over 5. So let's go and do that. P prime, our new image, negative 10 times 1/5 is going to give us negative 2. And 0 times any number is going to be 0. For Q prime, negative 5 times 1/5 is negative 1. Again, 0 times anything is just 0. For R prime, we're going to have 0, 1. And for S prime, we're going to have negative 1, positive 1. So those should be our new coordinates. We're going to go ahead and graph it and make sure our picture looks correct. If you notice, this scale factor is between 0 and 1, so our picture should be getting smaller. And since the center is at 0, 0, it's going to be moving closer to the center. So let's go ahead and graph these. P prime is at negative 2, 0. Q prime is at negative 1, 0. R prime is at 0, 1. And S prime is at negative 1, 1. So there's our image. If you notice, it got smaller by the sizing of 1/5. All right, the next problem, it says find the coordinates of the image of the polygon after a dilation centered at 0, 0 with scale factor k. So the same exact process, just this time we don't have a graph. This is actually easier because we're just multiplying the numbers and that's it. So our scale factor here is negative 6. That means every single number gets multiplied by negative 6. So for A prime, negative 3 times negative 6 is going to give us 18. For the 1 times negative 6 gives us negative 6. Next one, B prime, negative 4 times negative 6 is going to give us positive 24. And negative 1 times negative 6 is going to give us positive 6. And then our last one, C prime, negative 2 times negative 6 is positive 12. And negative 1 times negative 6 is positive 6. So there's the new coordinates for our new image. All right, the next problem, it says a biology book shows the image of an insect that is 10 times its actual size. The image of the insect is 8 centimeters long. What is the actual length of the insect? So for this one, we're still using our scale factor formula, which is new over old. And for this problem, the new is the 8 centimeters because that's the image in the book. And the old is 10 because it says in real life the insect is actually 10 times bigger than the image in the book. So from here, we just need to simplify. Both of those numbers can be divided by 2. So 8 divided by 2 is 4, and 10 divided by 2 is 5. You can either write these as a fraction, or you can write it as a decimal. 4 over 5 would be 0.8. And these are both in centimeters. For these kinds of questions, you always want to go back and check just to make sure you have the correct answer or that your answer makes sense. In this example, you're looking at a picture of an insect that's a lot bigger than what it is in real life. So if in the book it's 8 centimeters long, in real life our number should be smaller than that. So looking at our answer is 0.8, which is smaller than 8, so that checks out. All right, our last problem, it says describe a similarity transformation that maps the pre-image to the image. So looking at this picture, we know for sure the triangle is getting smaller because the ones with the apostrophes or the primes is our new image, which is smaller than the old one. So we're going to start this off by drawing a T-chart so that we can see exactly what's going on. Our first column is always going to be our original coordinates. So let's go ahead and list those out. We've got L, M, and N. L is at 6, 6. M is at 0, 4. And N is at 0, 6. We talked about how it gets smaller, so we're going to write out a dilation here. And for a dilation, we need a scale factor. This is pretty easy when we're looking at a graph. You just need to compare two sides of a shape. So let's go with the left side because that seems like it would be the easiest. From N to M on the original, that is 2 squares. From N prime to M prime over here, this is only going to be 1 square. So to get from 2 to 1, that is half of it. So our dilation, our scale factor, is going to be 1/2. So that means all of our numbers need to be multiplied by 1/2. So for L, 6 times 1/2 is 3. For M, half of 0 is still 0. Half of 4 is 2. And then for N, half of 0 is still 0. Half of 6 is 3. So we're going to go ahead and graph this and see what it looks like and see if that's the image that they ended up with. L is at 3, 3. M is at 0, 2. And N is at 0, 3. All right, so obviously that is not the answer they came up with. So that means we need to keep going and do something else to get their final answer. So from here, the shape doesn't change sizes anymore. It doesn't rotate. It doesn't flip. All it's doing is moving to the right and down a little bit. So we're going to continue with our T-chart, put another column here. If it's just moving, we call that a translation. So we need to write our rule for that, and we can just count boxes for this. So let's start with L. L is going to the right, 1, 2, 3, 4. So that means our rule should be x plus 4, because to the right is positive. And then it went down only 1. So it's going to be y minus 1 since it went down. So now we can go ahead and write in our new coordinates and see if it matches with this rule. So following your numbers, L is 3, 3. So plugging into the formula, x plus 4, it's 3 plus 4, which is 7. 3 minus 1 is 2. Moving on to M, 0 plus 4 is 4, and 2 minus 1 is 1. And our last one, letter N, 0 plus 4 is 4, and 3 minus 1 is 2. So now we're going to go ahead and check this, see if it works out. L is at 7, 2. Here is 7, 2. M is at 4, 1, which is right here. And N is at 4, 2, which is here. So yes, it does finally check out. So our similarity transformation that's happening here is a dilation of 1/2 and then a translation of x plus 4, y minus 1. All right, guys, that's it for today's notes. If y'all got any questions, please talk to your geometry teacher. I hope y'all have a great day. See y'all again next time.